Good morning, students. So in this video, we'll see the development of a cone. So unlike a pyramid, cone doesn't have any corners or edges for us to locate these cutting points. So in this question, a cone is given with a diameter of 60 mm and the axis is 70 mm and is resting on its base on HP. So the solid given is a cone whose dimensions are well defined. Now it is cut by a section plane inclined 45 degrees to the base and bisecting the axis. So the cutting plane goes to the midpoint of the axis and it is at an angle of 45 degrees to the base. Okay, so to draw this, first we'll draw the plan and the elevation of the cone. So we'll start with the XY line. First draw the XY line, then draw the plan, which is nothing but a circle of diameter 60 mm. And as I said earlier, there are no corners or edges. So we need to divide this into 8 or 12 equal divisions. So in this case, I have divided into 8 equal divisions. So first draw a horizontal line, then draw a line at an angle of 90 degrees or a vertical line, and you divide this at 45 degrees each from either side. So this will give you 8 equal divisions, and I've started numbering in the anti-clockwise direction. I've started from A here and then goes in the anti-clockwise direction. Then you draw projectors to meet the XY line and locate the points A dash, B dash, etc. up to S dash. Now the axis is given as 70 mm. So for drawing the axis from the baseline, you draw a line till O dash, which is at a distance of 70 mm. Now these are all construction lines. So these lines O dash, B dash, O dash, D dash, etc. are construction lines. Now maybe you can show this as an axis. Like when we are having three edges getting overlapped, like a visible edge, an invisible edge, and an axis, we'll give the first priority to the visible, then to the invisible, and third to the axis. So in this case, we can make this an axis. So we can convert this line as a chain line if you want, or probably you can retain the other one as well. Now the cutting plane is at an angle of 45 degrees to the base and it is bisecting it. So I am dividing the axis at this point. So I'm drawing a short line and this line is parallel to the baseline. So whatever be the angle the cutting plane makes to this short line will be equivalent to the baseline. So I'm making this angle as 45 degrees, the one which I have shown in red, and this is the cutting plane. So this cutting plane cuts all the generators. So for construction purpose, I have shown all the generators here. Now I need to transfer this into the development. So the development of a cone is nothing but a sector. A sector means it's a part of a circle, a part of a circle, and we need to find out what will be that angle. So I'll come to that area. Now we'll come to the development part. Now for that, we need to draw or we need to find out which of these slant will give the actual dimension. If you see that O dash, A dash, and O dash, E dash will have the same dimension, but O dash, B dash, or O dash, G dash, which will be reduced in length. So you have to find out which slant edge will give the true length in the elevation. For that, you look at the plan. In the plan, you can see that only OA or OE is parallel to XY line. So either O dash A dash or O dash E dash will give the true length. So you have to start drawing the development using O dash A dash or O dash E dash as the dimension. So to draw the development, you locate a point O, probably you can draw on the side of this elevation and draw OA in such a way that it is equivalent to the length O dash E dash. Now you draw an arc with OS center and OA is radius, and you have to find out this angle theta, which is nothing but 360 into this radius OE divided by this length O dash E dash, that is 360 into OE by O dash E dash. That will give you the angle. So actually the actual procedure is you have to find out this sector. So to find out the angle theta, and then you have to divide that theta into 8 equal divisions. So if you have taken 8 divisions of the circle, then here also you have to take 8 divisions. So another easy method is that you can start with the line OA, then you draw an arc of some comfortable length. Then you take this arc length OA, take this arc length from the plan in compass. Then you start from the point A and mark the points B, C, D, etc. etc. That will be approximately equal to those lengths. So you can mark these points around this, and this will be approximately equal to this arc length. Now you join OA, OB, OC, etc. OA, OB, OC, OD, etc. OA, and this gives the development of the cone. Now you are asked to draw the development of the remaining portion. So this is a question. So if you are asked to draw the development of the cone, this is the answer. But there is a cutting plane which is bisecting the axis, and you are asked to draw the remaining portion alone. So in this case, you have to locate these points. You can see that the cutting plane is touching O dash, A dash at this point, O dash, H dash at this point, etc. etc. But the thing which you have to keep in mind is that we have drawn OA, which is equal to O dash E dash, and the inner generators are not of that equal length. So you have to plot all these points to the outer generator. O dash A dash is the same. Then you have to get this point on the outer line. So this point will correspond to the point where the cutting plane touches O dash B dash and O dash H dash. Similarly, you find all other points along the outer line. So this is a true length line which we have used for plotting the development. So once you have located all the points on the outer generator, now we can transfer these points to development. So in a compass, you take the distance O dash till this point where it touches O dash A dash and transfer it to the line OA. Similarly, you take the other point which will be transformed to the outer generator, and you locate all these points on, say I'm marking it as red points on this development. Now for a cone, if you are having a cutting plane, the surface will be in an arc. So if it is a pyramid, we have to join these points using straight lines, and if this is a cone, it's a cone or a cylinder, you have to join them using a curve. So either you can use French curves or you can go for what to say freehand sketching. So while you're doing freehand sketching, make sure that the two halves are symmetric. So OE is a middle line. So on either side of OE, the curve should be symmetric. So you go for a light sketch. So even if you go wrong, you can erase it without, I would say, keeping any mark on the paper. And once you get a perfect curve, you can darken it. So join these points using a smooth curve. And then you can join, or then you can darken the outermost points alone. So you darken the outermost curves. So why? Because the inside parts are all generators. So you need to darken these points. And this curve also, it should be dark. Okay. So write the equation for finding the angle theta. So for the examination, you have to find out the angle theta. So theta will be 360 into R by L, where R stands for the radius which is OE in this figure, and L is a slant edge which is O dash E dash. So this will give the angle theta. So you have to mark the angle theta here. So whatever angle you get, you have to mark it over here, and this is an easy method for construction purpose. So as usual, you have to mark the diameter and the height. Diameter, you can put an arrow like this, and you can write, if you are writing radius, you put R, or if it is diameter, you put 560, and the height also you can show here. So this completes the development.